Hey algebras! So today's lesson is about quadratic equations. And basically what we're doing is taking what you're used to having as a polynomial and we are turning it into an equation by adding an equal sign and then a value. So the interesting thing that we'll talk about is sometimes your equation is going to be set equal to 0, and that's going to be when you are solving the quadratic. If you wanted to graph the quadratic and you wanted to see what it was like as a function, you could say ax squared plus bx plus c is equal to y. And this would be when you are graphing and looking at the quadratic as an equation. So we're going to do some fun stuff on Desmos this week in class that I want you to take a look at and understand what we're talking about here. Okay, so here's some big ideas. Quadratic equations are functions. That means that we can write them with an input and output table where we have our input domain values and our output range values. We can take those values and we can set them on a graph. So we can have a graph, for example, that is positive and a graph that is negative. These kinds of graphs are called parabolas. The graphing characteristics are as follows. First of all, the curved graph is different from what you're used to. Our linear graphs that we had as straight lines are going to be changed because we have this nonlinear symmetric curve. So our graph is called a parabola and it looks like a U-shaped curve like that. Our vertex is going to be this point here that is either the minimum, or if the graph is negative, your vertex is going to be a maximum. So here's your vertex as a minimum and your vertex as a maximum. If your equation is positive, it opens up like a cup. And if your equation is negative, that graph is down like a frown. Your line of symmetry is going to be a vertical line that can be drawn right in the exact middle of the graph. And it's almost as if you were going to fold the graph in half. That's going to be our line of symmetry. And that graph is going to go through the vertex. So your vertex is, or your line of symmetry is going to be an x is equal to equation where this value here is going to be your x value of your vertex. This is going to match. Your solutions are going to be your x-intercepts. That's any xy ordered pair that gives you an output of 0. And that's where that graph crosses the x-axis. Okay, so what we're going to do in class today is we're going to graph our equation with Desmos. And what you're going to do is you're going to put the equation right in and you can see 3 different characteristics. I want you to look for your vertical line of symmetry. That x is equal to equation, that's that vertical line that where the graph can fold in half. Your vertex is either going to be a minimum or maximum, and you need to be able to decide whether the picture of the graph is up like a cup or down like a frown. Your solutions are going to be where that graph crosses that x-axis. Okay, so here we are on Desmos, and what I want you to be able to do is I want you to go ahead and type in an x, and there we have our straight line. That's our parent function when we have just an x, and when I square it, watch what happens. That is the curve. If I wanted to see my input-output, I can go to my edit my task and add a table. That quadratic, that squared function adds a couple of important aspects to our graph. Notice it increases exponentially, and that's how you get the curve. We don't have a slope. We don't have a constant rate of change. But what we have instead is that increasing. 1 times 1 is 1, but 2 times 2 is 4. And 3 times 3 would take us all the way up to this point here on the graph, where I would have over 3 up 9. So what's neat about Desmos is we can type in any quadratic and we can have that equation as it was originally. The important points for us to look at is going to be this line of symmetry, and it's going to be the x is equal to line that folds the graph in half. So here we have x is equal to 0. This point here as our minimum is our vertex, and when I do my line of symmetry, it's going to be x is equal to this x coordinate here of this vertex, this xy ordered pair. If my graph is sitting on the x-axis, my x-intercepts are going to be the same as my vertex. But notice what happens when I just change my graph slightly. X minus 4. Now here's my vertex down at 0, negative 4. Notice my line of symmetry still is the same, but now I have these 2 points that are called solutions. Our solutions in a quadratic equation is where the graph crosses the x-axis. If I go back to, again, looking at that table of values, I can see that both negative 2 and positive 2 give me an output of 0. When we solve a quadratic equation, we wind up with not one but 2 possible answers because that graph curves around. So on the worksheet, what we have you doing is entering in a couple of these equations and looking at what happens as a result. Your first equation is your x squared. Your next equation that I want you to enter in is going to be the opposite of x squared. And notice what happens to my graph. That negative that's out in front of the x makes my graph go down like a frown. The next graph we're asking you to do is go ahead and put a 2 there. And when you fill in the table of values, remember, you can go up and click on your Edit Your List, and you can ask for a table of values. And what you can see is that coefficient of 2 makes my graph taller and skinnier because each of my output values is now twice of what it was before. If I have a fraction in front, we can see that that graph is now open more. And if I want to, I can go ahead and compare what that looks like with my original, and then I can compare that with what that looks like with the graph that has the 2. So this blue is my original, y is equal to x squared. This skinnier graph is when I have a coefficient of 2, and this fatter graph is the one where I have a fraction coefficient, and that's the one that makes the graph open up wider. So your next couple problems on the packet talk about how not every graph is going to be centered on this y-axis with a vertical line of symmetry that is equal to the y-axis. What we might end up with instead is a quadratic, y is equal to x squared, and we can say that it's minus 5, and then it drops down. We can say that it's plus 2, plus 2, and then it goes up. The interesting part of the graph comes from when we start moving equations all around our x-axis or all around our x and y axis. So by having a minus 8x plus 16, notice that this graph has been shifted over to the right. So my vertex, my very bottom point, is now at 4, 0. So when I go to write the equation of my line of symmetry, it's going to be x is equal to 4, because that's where that equation goes. If I, on my next one, where I have x is equal to, or y is equal to x squared plus 7x plus 10, now this one's interesting because my graph not only moved to the left, but it also went down. When I look at my vertex point, finding that line of symmetry, I again have to look at that x coordinate. So when I go to write my equation, I'm going to have to say x is going to be equal to negative 3.5. This line here, vertical line, shows you where the graph falls in half, and I get that value from that negative 3.5. So this takes you all of the graphing examples that are on this worksheet. Go ahead, open up Desmos and give it a try.